The system did not fail you. It executed precisely what you allowed to exist. You treated identity as a modeling choice, a design detail, something you could defer to later, or patch in ETL, or push into a best practice document nobody reads at 2 a.m. during an incident. The platform never shared that belief. Underneath every dashboard, every semantic model, every Lakehouse table, there is only one question that matters. When two rows appear related, are they the same entity or are they not? If the answer is not enforced, it is guessed. And when it is guessed, everything built on top becomes probabilistic. For years, you lived on that probability. You trusted email addresses to stay stable. You trusted composite natural keys to remain unique. You trusted upstream applications to do the right thing. You treated uniqueness as something that would emerge from process and discipline. Entropy treated it as a weakness. At small scale, this masqueraded as noise, a few duplicate customers, a double-counted metric, a report that looks off but passes acceptance because nobody can prove the ground truth. At fabric scale, that same weakness is not noise, it is a force. It amplifies through every join, every aggregation, every AI query. Identity columns in Microsoft Fabric are not a convenience. They are the point where the engine stops pretending uniqueness is optional. They are deterministic enforcement injected at the moment where ambiguity either collapses into a single truth or propagates into permanent divergence. You were not missing a feature, you were operating without physics. Today, you will see why natural identity was never real, why application logic always loses against concurrency, and why Fabric, under pressure, had to assert ownership of causality itself. Not as an improvement, as a necessary constraint, the illusion of natural uniqueness. Your entire mental model of data identity started from a human shorthand. You look at a person, read their name, maybe their email, and you declare, same person. You extend that intuition to systems. You decide that a customer ID, an order number, a product code is enough. You elevate those fields into natural keys and assume they carry identity. They do not. They carry state. A customer ID is a token in an upstream system. It exists because some application emitted it. That application can reassign it, recycle it, or misgenerate it under pressure. An email address belongs to a human for as long as the directory says it does. When they change roles, merge accounts, or leave the organization, the identifier can be retired, reissued, or aliased. From the system's perspective, none of this implies continuity. It only sees tokens and timestamps. You believed uniqueness would emerge from social convention. We never reused these IDs. We always enforce this constraint. We don't allow duplicates. Those sentences are not laws. They are wishes expressed as policy, implemented by humans, bypassed by integrations, silently violated during migrations. Entropy does not negotiate with policy. In a lakehouse, the problem becomes physical. You ingest from multiple sources, each with its own interpretation of identity. CRM, billing, HR, telemetry, line of business databases, all shipping rows tagged with keys that are only unique inside their own local belief system. You then land them into a shared storage substrate and act as if those beliefs will align. They do not align, they collide. The result is entity divergence. One human appears as 3 customers. One asset exists as 5 rows, each with slightly different attributes and activity histories. One employee code shows up connected to 2 different people because HR fixed a past error without understanding that downstream that code was treated as permanent. No engine-level enforcement is present to arbitrate. There is no column that the platform itself owns and defends as the non-negotiable identifier. So every subsequent operation, join, group, filter, operates under a probabilistic assumption that your natural keys are still clean. They are not. They decayed the moment they left the original system. The thing you called a natural key is a description, not an identity. It describes how the business currently thinks about grouping rows. It does not describe how the engine experiences rows. The engine sees only tuples and constraints. When no constraint exists, every insert is accepted. Every duplicate is legal. Every backfill can replay the same entity twice with slightly different attributes and no structural resistance. You see the same customer updated. The system sees 2 valid rows with different values. You then project that confusion into your semantic layer. Power BI happily aggregates both rows. It doubles revenue, splits headcount, or smears activity across pseudo-entities. The dashboard does not crash. It does not throw. It renders numbers with full confidence because technically nothing is wrong. You never told the system those rows must be mutually exclusive. This is the illusion of natural uniqueness, the belief that identity pre-exists the system and that storage merely reflects it. In reality, the system only acknowledges identity to the extent that you encode it as a constraint. Without that, you are not missing a primary key. You are running a high-throughput ambiguity machine. Fabric's Lakehouse amplifies this because it removes friction. Landing more data becomes effortless. But friction was the only thing limiting how fast identity drift could spread. When you accelerate ingestion without engine-owned identity, you accelerate divergence. The system is not creating chaos, it is scaling your assumptions. Identity columns are the first time the engine itself asserts. This row has a unique, immutable surrogate that no external actor may control. A begint sequence no human can reseed, no ETL can fake, no application can reuse. It is not friendly, it is not ergonomic, it is the minimal enforcement required to pierce the illusion that natural keys were ever enough. The physics of data entropy. Entropy in your platform is not a metaphor, it is a measurable tendency for distinct entities to diverge, duplicate and blur over time unless you spend energy to prevent it. In information theory, entropy quantifies uncertainty. In your data estate, entropy quantifies how many different interpretations of the same thing now coexist without a referee. Every new source, every schema change, every backfill increases the number of possible states your system can represent for a single entity. You like to think drift is an exception. A bad migration, a one-off bug. It is not. Drift is the default trajectory of any system that does not enforce identity at the engine level. Look at your Lakehouse as a thermodynamic system. You have continuous inflows, operational databases, SAS exports, flat files, event streams. Each brings its own temperature, its own conventions for keys, timestamps, and update semantics. You have transformations that reshape, aggregate, and denormalize. You have backfills that replay old partitions with new logic. You have AI workloads reading and writing derived artifacts. Each of these steps introduces opportunities for divergence. A source adds a nullable column that becomes part of your de facto natural key. One feed populates it, another does not. A late arriving event is ingested after a slowly changing dimension was already materialized. A backfill replays 3 years of data into the same table without a predicate tight enough to prevent overlaps. The system accepts all of it. It is doing exactly what you configured. Append rows, update files, rewrite partitions. At no point does the engine stop and ask, are these two records mutually exclusive representations of the same entity? It cannot ask that question. You never gave it a column that encodes the answer. So entropy accumulates, not as visible errors, but as alternative histories. In one partition, customer 123 has address A. In another, customer 123 has address B. In a late arriving feed, customer 123 is missing entirely, replaced by a new ID from a merged system. Your semantic model chooses one version based on load order, filter logic, or sheer accident. Your AI feature store chooses another based on a different join. You experience this as inconsistency. The system experiences it as perfectly valid state. Without engine-level constraints, every table trends toward maximum representational freedom. Many rows that could be the same thing, none of which are structurally prevented from coexisting. That is high entropy. To push against that, you must spend energy. In classic databases, that energy is encoded as primary keys, unique indexes, and foreign keys. Every insert is evaluated against those rules. Violations are rejected, entropy is locally constrained, the cost is lock contention and occasional failures. The benefit is determinism. In a lakehouse without identity columns, you removed that energy source. You decided performance mattered more than enforcement. You pushed identity into pipelines, notebooks, policies, governance documents. You externalize the cost. Fabric by design amplifies whatever exists. If you feed it high-entropy inputs with no engine-owned identity, it will produce high-entropy outputs at scale. Dashboards, AI models, and downstream marts will all reflect the same underlying fact. The system is not sure which row is which. Identity columns reintroduce a hard boundary into that physics. A begint surrogate generated inside the warehouse engine is not about readability. It is about collapsing the space of possible interpretations. One row, one identifier, for the lifetime of the table. That identifier is never reused, never reseeded, never supplied by external logic. You still have drift. Attributes change, sources conflict, versions accumulate, but entropy is now constrained around a fixed anchor. Every representation of that entity in your warehouse either maps to that surrogate key, or it is a different entity by definition. Replay becomes a proof instead of a guess. Delete the table, re-ingest from the same raw data with the same transformation logic. If the engine owns identity, the surrogate keys assigned will follow the same deterministic pattern across nodes. The causal graph of your data, the way facts relate to dimensions, the way events relate to entities, reconstructs identically. If identity is external, replay is another random walk through possibility space. You are not fighting bugs, you are fighting physics. Metaphor, the clock without a ticking mechanism. You built a clock. You wired ingestion, transformation, and reporting into something that looks like time. Data arrives, pipelines run, dashboards refresh on schedule. People watch the needles move and assume sequence exists. It does not. Without enforced identity, your platform is a clock face, bolted to a wall with no escapement, no gear train, no mechanism that forces discrete, irreversible ticks. The hands move because you repaint them, not because time advanced. In this model, rows are events, identity is the gear, causality is the tick. When a fact table receives a new transaction, that is an event. When a dimension row changes, that is an event. When an external system replays 3 years of history, that is a dense stream of events. You experience that stream as time, but unless the engine ties each event to an immutable surrogate, nothing links before and after into a provable sequence. You rely on timestamps instead. You sort by created at, and you tell yourself you reconstructed order. You did not. Timestamps record when the system claims it observed something. They are not proof of causality. They are not unique. They are routinely truncated, rounded, or overwritten. Two inserts from different systems can land with the same millisecond value. Late data can arrive with an earlier timestamp than rows already stored. Clock skew between upstream sources makes now relative, not absolute. Your clock displays a time. It cannot prove which moment produced which state. Now take this into replay. You delete a table. You rerun the pipeline from bronze to silver to gold. The same source files are read. The same transformation code executes. The same business logic supposedly applies. If identity is external, the engine is free to assign different internal row orders, different partition layouts, different join plans. The visible results might look similar. The aggregate counts might match, but individual rows, those pseudo-entities you thought were stable, can shift. The same customer's history can bind to different surrogate integers. The same event stream can attach to a slightly different sequence of dimension versions. From your perspective, the hands of the clock return to the same position. From the system's perspective, it built an entirely new mechanism behind the face. You cannot prove that this replay represents the same causal history. You can only assert that it is close enough. Identity columns introduce the ticking mechanism. Inside Fabric's warehouse, a big int identity does not care about your business meaning. It cares about sequence as experienced by the engine. Each successful insert produces one irreversible step. Values are allocated across nodes, ranges are reserved, and once a number is consumed, it is never reused for that table. You lose continuity in the sense humans like neat, contiguous sequences, predictable increments, human-readable patterns. You gain continuity in the only sense that matters to the system. Each physical row occupies a unique coordinate in engine time. Now, when you replay, you are not asking, did I get roughly the same result? You are asking, did this transformation applied to this input reconstruct the same identity graph? If identity is engine-owned, the answer is deterministic. The mapping from events to surrogates follows the same distributed allocation rules. The dimension row that represented a given state last time will receive the same surrogate this time because the insertion pattern relative to other rows is identical. Your clock now ticks. Facts reference dimensions through stable keys. AI features reference entities through stable keys. Lineage systems can trace a single surrogate from raw ingestion through every derived artifact. When something diverges, you can prove exactly where the tick sequence changed. Without identity enforcement, you never had a clock. You had a painted dial, a set of assumptions, and a hope that time would respect them. Fabric's identity columns are not decorative. They are the escapement. They are the component that converts an unbounded stream of events into discrete, non-negotiable steps. You are not adding convenience. You are installing physics. Incident 1. The silent bias of Power BI. Now you see what happens inside the store. Watch what it does to the instruments on the wall. You open Power BI. You connect to your lakehouse or warehouse. You build a simple model, a customer dimension, a sales fact, a few measures. Nothing exotic, just headcount, revenue per customer, maybe churn. In your dimension, customer business key is not enforced as unique. Nobody told the engine it must be. Somewhere upstream, the same human has been ingested twice. Same business key, slightly different attributes. Maybe one record carries an old email. Maybe one carries a new region. Maybe one came from CRM, one from billing. The model imports both rows. You then define a relationship from sales. Customer business key to customer business key. Power BI accepts it. It does not challenge your assumption. It cannot. You never marked that column as a key. The semantic model has no obligation to treat it as unique. Now, a simple measure, distinct customers equals distinct count customer business key. The number looks plausible. You compare it to a report from CRM. It is off by a few percent. You explain it away. Timing differences, filters, business definitions. The number passes. Underneath, that one duplicated customer contributes twice to the distinct count. Every duplicated entity does. Your per customer revenue is now diluted. Your churn rate is now blurred. Your segmentation logic built on top of that dimension is silently biased. Nothing crashed. No error appeared. You can publish the report, certify the dataset, and wire it into executive dashboards. The platform did exactly what you modeled. It counted distinct values in a column. That column contained duplicates because you allowed them. The dashboard did not lie. It aggregated what you allowed to exist. This is the first incident. Aggregate corruption without incident response. No Sev A, no page. Just slow, routine decisions made on top of numbers that feel deterministic and are not. You might try to patch this after the fact. You add filters to remove obvious duplicates. You add a DAX measure that picks latest customer record by modified at. You bury the selection logic inside a calculated table. You convince yourself the semantic layer can retroactively enforce identity. It cannot. All you are doing is choosing which duplicate wins today. Tomorrow, a backfill lands an older record with a newer timestamp. Your latest logic flips. Historical reports recompute. KPIs shift without any corresponding real-world event. From the system's perspective, this is still valid. It applied your rules to the rows present. The fact that those rules are built on a non-enforced assumption of uniqueness is not its concern. Now connect AI.Copilot for Power BI inspects your model. It sees a customer table, measures relationships. You ask, show me top 10 customers by lifetime value. It queries the same biased aggregates. It returns a ranked list with confident narrative, who your best customers are, which regions dominate, which segments drive value. Every sentence is grounded in the model. The model is grounded in ambiguous identity. Power BI is not malfunctioning. Copilot is not hallucinating. They are both faithfully executing over a graph where one human can occupy multiple conceptual nodes with no structural violation. You are not looking at analytics. You are looking at a well-rendered, highly optimized projection of your entropy. This is why deterministic identity is not a visualization concern. By the time a metric appears on a canvas, the physics have already decided whether it can be trusted. Identity columns push that decision down into the engine where it belongs. Without them, every Power BI success story you tell is built on an unproven assumption that customer was ever a unique thing in your warehouse at all. The failure of application-level logic. Now watch how you tried to cheat physics. You saw the cracks, duplicates, split identities, silent bias. Instead of surrendering identity to the engine, you pulled it up into the application layer and declared the problem solved. You wrote logic. You told pipelines to generate IDs. You told notebooks to enforce uniqueness. You told orchestration to handle conflicts. You moved identity out of the one place that can enforce it deterministically and into the one place that is guaranteed to drift, your code. The pattern is always the same. You compute max ID plus 1 in a staging table. You use row number over some sort key to fabricate a sequence. You hash a set of business columns to create a pseudo-surrogate key. You decide that if everyone follows the contract, collisions will not happen. The system executes that contract with perfect obedience until concurrency appears. In a distributed lakehouse, concurrency is not an edge case. It is the default operating mode. Multiple pipelines ingest the same entity from different regions. Multiple notebooks backfill overlapping time windows. Multiple teams deploy updated transformations against the same tables. Your maxid plus one logic runs in processor while process B is still writing. Each sees the same maximum. Each allocates the same next ID. One fails with a conflict at commit time if you are lucky. One silently overrides if you are not. In both cases, the sequence is no longer a sequence. It is an accident. Your row number logic generates clean integers inside a batch. But row numbers are not persisted by the engine. They are recomputed every time the query runs based on whatever ordering the optimizer chooses that day. Use that value as a key, and you have built identity on top of a non-deterministic plan choice. Your hash-based keys depend on a stable definition of same. Add a column to the hash set, and all existing entities are now different. Backfill with the new logic, and every historical row acquires a new identity. The old keys remain in downstream facts. The new keys appear in slowly changing dimensions. The link between them is tribal knowledge. You then wrap all of this in orchestration. You say only one pipeline runs at a time. You say we do not backfill more than once. You say this notebook is for initial load only. You rely on convention to protect you from race conditions. Entropy treats those conventions as attack vectors. A new engineer parallelizes a job to meet an SLA. A consultant writes a one-off migration script that reuses the same ID range. A recovery procedure replays a folder twice. Every workaround you wrote to simulate engine behavior is now a liability. It executes precisely as designed until the first unmodeled interaction occurs. At that point, there is no single locus of truth. Identity is smeared across code, configuration, and hidden assumptions. So the platform does not intervene. Fabric's engine will happily accept whatever ID you hand it in a big int column you pretend is a surrogate. It will distribute inserts across nodes, commit files, and expose the table through SQL and Power BI. It has no intrinsic reason to distrust your application-level sequence. It cannot distinguish your fake physics from actual constraints. That is the core failure. You tried to replicate determinism in a layer that cannot enforce it. The application tier is mutable. It is versioned, redeployed, refactored, and replaced. Pipelines are edited, notebooks are copied, data flows are cloned. Every change to that logic is a change to how identity is assigned. The engine tier is not mutable in that way. Identity columns in Fabric cannot be reseeded. They cannot be overridden. They cannot be manually populated with identity insert. The system deliberately withholds those escape hatches because every one of them is a path back to application-level chaos. When you generate keys outside the engine, you are not being clever. You are assuming responsibility for concurrency, distribution, ordering, and replayability across every execution context that touches that table. You will not carry that load consistently. Fabric's identity columns are the admission that this burden never belonged in your code. They relocate identity generation to the only actor that can observe all writes, coordinate all nodes, and refuse all violations. The moment you accept that, every clever workaround you wrote stops looking like engineering and starts looking like entropy disguised as logic. Incident 2. Lakehouse identity collapse. Now move from biased instruments to the store of record itself. The Lakehouse is sold to you as Convergence. One place, one copy, one truth. You centralize data from CRM, ERP, HR, finance, telemetry. You convince the organization that everything lives here now. You do not give the engine identity. You lend raw zones, bronze, silver, gold. You partition by date, by region, by business unit. You append, you upsert, you merge. You backfill last quarter, you reprocess last year. You migrate a legacy warehouse and stitch it into the same tables. Every one of those operations carries a belief about same customer, same employee, same asset. None of those beliefs are enforced as constraints. They are encoded as join conditions. You then hit the first real test, a structural change. The CRM system is replaced. Customer IDs change format. Some are mapped, some are retired. HR merges two employee directories. Asset management rekeys equipment after an acquisition. Each upstream team promises we preserved mappings. They ship CSVs with old and new keys, maybe with effective dates. You write transformation logic to align histories. You treat these mapping tables as oracles. You believe they will remain correct under backfill. Then the inevitable happens. A late migration file arrives with slightly different mappings for a subset of customers. A vendor reruns an export with corrected joins. Someone notices a gap and replays 12 months of CRM into the same landing folder. Your Lakehouse tables accept all of it. The same human now appears as multiple final keys, depending on which mapping was applied at which time in which pipeline. Old key to new key mapping A was used in one run. Mapping B was used in another. Both results are present. Both are considered valid because no surrogate in the warehouse asserts that these rows are mutually exclusive. From your perspective, identity has collapsed. From the engine's perspective, nothing broke. It has two rows, each with distinct values, each passing type checks. The Lakehouse did not lose identity. It never owned it. This is not a theoretical edge case. It is how large organizations actually evolve systems. They replace applications incrementally. They migrate in waves. They discover bad mappings and correct them after data has already flowed downstream. Without engine-owned surrogates, every correction is an addition, not a substitution. You think you are fixing customers. You are forking them. Facts already loaded against the old representation remain bound to that phantom entity. New facts bind to the corrected one. Backfills bind to whichever path the code took that day. The entity graph becomes a probabilistic cloud around each real-world object. No row is wrong in isolation. The constellation is wrong as a whole. Replay makes it worse. You decide to standardize all history under the new keys. You truncate silver. You replay bronze into silver with updated mapping logic. Some paths now collapse, others split differently, some drop entirely because the mapping files no longer contain obsolete keys. If identity is external, the warehouse produces a new universe. Facts reconnect to different dimension rows. Slowly changing dimension versions roll up under different anchors. Time series attached to customer X last week now attached to a different representation of customer X this week. You have not just changed state, you have changed which state was ever considered real. In this environment, lineage diagrams lie to you. They show arrows from raw to silver to gold. They show tables feeding reports. They do not show that the referent of a given business key has shifted 3 times in a year with no structural trace. Engine-level identity columns change that physics. When the warehouse owns a big-int surrogate for each customer, each employee, each asset, migration mappings become translations to that anchor, not creators of new anchors. A bad mapping attaches the wrong business key to an existing surrogate. Fixing it corrects attributes without minting new identities. Backfills replay events against fixed surrogates. New systems supply new natural keys that are resolved once deterministically into existing or new surrogates. The entity cloud collapses around stable coordinates. Now, when you truncate and replay, you are not asking the platform to invent a fresh ontology. You are asking it to recompute attributes and relationships around the same identity graph. If removing identity columns would cause that graph to mutate under replay, your architecture was not stable. It was a snapshot of a negotiation between code paths. The Lakehouse did not betray you. It revealed that you never gave it ownership of identity. The inevitability of replay and divergence. Replay is not an operational convenience. It is the only honest test of your architecture. If you cannot delete a dataset, rerun the exact same inputs through the exact same transformations and reconstruct the same identity graph, then your system never owned causality. It only produced a plausible history once. In a deterministic platform, replay is boring. Same files, same code, same keys. Facts bind to the same dimensions. Slowly changing entities follow the same version paths. Lineage diagrams are not just decorative, they are verifiable. A surrogate key sequence is an irreversible record of how the engine experienced time. In your current Lakehouse, replay is theater. You re-execute pipelines to prove recoverability. You validate row counts. You check aggregates. You declare success when totals align. You never compare identity, because you cannot. There is no invariant anchor to compare against. The absence of identity columns makes divergence inevitable. Distributed engines are free to choose different join orders, different partitioning, different write patterns on every run. Without engine-owned surrogates, those choices leak into identity. The same business entity can emerge from replay with different internal coordinates. The same customer 123 is now row 5, then row 17, then row 42, each time linked to slightly different attribute histories. You call this non-deterministic behavior. It is not. The system is perfectly deterministic given its current plans, statistics, and inputs. It is your notion of identity that drifts because it is not bound to anything the engine treats as physics. Timestamps do not rescue you. They shift under backfill, under late arriving data, under clock skew. Hashes do not rescue you. Change the hash definition and you rewrite the past. Application-generated IDs do not rescue you. Concurrency and code evolution guarantee that over time, the same entity will be minted under multiple keys. Under these conditions, every replay is a forked universe. Your observability stack shows pipeline succeeded. Your BI layer shows numbers match within tolerance. Your AI workloads happily retrain on the new graph. None of them can tell you whether the identity space itself remains stable. This is where identity columns in Fabric change the game. A big int identity generated by the warehouse engine is not a label. It is a causal coordinate. Each insert consumes one. That mapping from event to surrogate is part of the system's execution, not your code's suggestion. It is governed by the same distributed allocation algorithm on every run. When you replay with identity columns in place, you are not relying on row order or timestamp heuristics. You are testing whether the same inputs under the same transformation logic traverse the same causal path through the engine. If they do, the same surrogate sequences appear. If they do not, you have proof of divergence at the only level that matters. This is the definition of owning your system. Identity is no longer a side effect of application behavior. It is an artifact of engine execution. Without that, your lineage story is fiction. You cannot assert that fact F was always linked to dimension D through history. You can only assert that right now, some join produces that pairing. If a future replay silently rebinds F to a different D, your audits become unprovable. Replay will happen. Migrations, corrections, model changes, regulation, disaster recovery, they all force you to run history again. With application-level identity, each replay is a new negotiation with entropy. With engine-level identity, each replay is a verification that causality is still intact. Divergence is not a risk. It is the default outcome when you refuse to give the system an invariant anchor. Identity columns are that anchor. They are the point where Fabric stops letting replay reinvent your universe and starts treating it as a test you can fail. The architectural boundary, transformation. You now know where entropy comes from. The only remaining question is where the system is allowed to stop trusting you. That boundary is not ingestion. Ingestion is the membrane between your chaos and Fabric's storage. Files arrive, streams land, tables are mirrored. At this layer, ambiguity is not a bug. It is a requirement. If ingestion refused anything without pristine identity, most of your critical data would never enter the platform. The engine accepts conflicting keys, overlapping histories, and inconsistent schemas because its only job here is to persist what happened upstream. It writes down your contradictions with perfect fidelity. The boundary is not consumption. By the time a semantic model or a report or an AI workload touches the data, identity has already either been enforced or abandoned. Consumption layers can choose filters. They can choose which version of an entity to expose. They cannot retroactively mint causality. When you try to fix it in the model, you are painting numbers on a broken clock face. Fabric's only rational place to assert ownership is the transformation layer. Transformation is where raw inputs are minted into ordered truth. It is where bronze becomes silver, silver becomes gold. It is where you decide which rows are facts, which are dimensions, which attributes are slowly changing, which keys define grain. Every one of those decisions is a statement about causality. If the engine does not enforce identity here, it never will. This is why Fabric's identity columns live in warehouse tables, not in file metadata, not in Power BI models, not in Copilot configuration. The warehouse is the transform boundary made concrete, structured, relational, constrained. It is the first place the system can say, from this point forward, this row has a non-negotiable identity that exists independently of any upstream token. Inside this boundary, surrogate keys must be generated, not inferred. You do not reuse business keys as primary identifiers. You do not delegate sequence to pipelines. You let the engine assign a big int surrogate at the moment the row crosses from ingested representation to modeled entity. That is the tick where the escapement engages. Before it, events are unanchored. After it, every downstream operation is defined in terms of those surrogates. Transform is also where referential integrity becomes enforceable again. In files, you cannot guarantee that a fact references an existing dimension row. In a warehouse with identity columns, you can. Facts carry foreign keys to engine-owned surrogates. Joins are no longer best effort guesses on composite natural keys. They are deterministic resolutions against a constrained space. This is what Fabric stops trusting upstream identity at transform actually means. It continues to ingest whatever upstream systems emit. It continues to expose whatever tables you build to any consumption tool. But at the point where you ask the platform to treat something as a dimension, as a fact, as a conformed entity, Fabric asserts its own physics. Surrogate key sequences become the irreversible log of that physics. Timestamps become supporting evidence, not identity. Replay events become proofs that the same transform produces the same surrogates. Fabric does not correct identity at ingestion. It asserts ownership at transformation. That is where ambiguity ends. Outside that boundary, ambiguity is tolerated, even required. Inside it, ambiguity is a design error. If you try to smuggle application-level identity past this line, the system will still execute. But every property you claim, lineage, auditability, AI governance, will be fiction. The transform layer is not just another step in a medallion diagram. It is the jurisdictional border between human belief and machine determinism. You either let the warehouse own identity there, or you accept that your entire platform remains a probabilistic approximation dressed up as a data model. There is no third option. Identity columns as causal anchors. You have seen identity columns as a ticking mechanism. Now you will see them as anchors. An anchor is not a label. It is a fixed point in space-time that every future calculation must respect. In a deterministic platform, identity is that anchor. Everything else is commentary. When you define a big int identity in Fabric's warehouse, you are not asking the engine for a handy counter. You are giving it the right to assign causal coordinates. Each value is a specific, irreversible acknowledgement. This row exists in this table, and the system has bound a unique coordinate to it. From that moment on, every join, every foreign key, every lineage trace is no longer by agreement. It is by enforcement. You lose control. You cannot choose the starting point. Fabric does not support seeds or custom increments for identity. You cannot choose the pattern. Values are allocated across nodes in ranges, not in neat sequences. You cannot inject your own numbers. Identity insert is disabled. You cannot recede to rewrite history. That loss is intentional. Human discretion over identity is the source of drift. Every time someone fixes a key, compresses gaps, or reuses a range, they are asserting that causality is negotiable. Fabric's implementation removes that surface area. The warehouse engine is the only actor allowed to decide which events consume which coordinates. The trade is simple. You surrender aesthetics. You gain determinism. Look at a dimension table built around an identity surrogate. Business keys arrive dirty, duplicated, or remapped. The warehouse assigns surrogates in the order it accepts rows. Multiple natural keys can point at the same surrogate over time. The same natural key can point at different surrogates if the business genuinely splits an entity. But the mapping between surrogate and physical row is not up for debate. Facts reference that surrogate. AI features reference that surrogate. Lineage systems follow that surrogate. When a correction occurs, you change attributes or reassign business keys. You do not change the anchor. This is what stops alternative histories from silently coexisting. Without an anchor, your customer 123 can be redefined 3 times, and every time downstream joins will happily recompute reality. With an engine-owned surrogate, customer 123 is now just an attribute. The real identity is the big int the system emitted when it first accepted that row. Change the business key, and you are updating a description, not moving the anchor. That distinction is everything. It is why replay becomes a validation instead of a reinvention. It is why audits become about proving that surrogate X had these attributes at these times. not about arguing whether customer 123 meant the same thing last year. It is why referential integrity in the warehouse is no longer a set of polite constraints, but a concrete graph the engine defends. The anchor also survives scale. Distributed identity allocation in Fabric means values are not ordered globally, but they are unique by construction. Node A and Node B can ingest in parallel without coordination at the application tier. Ranges are pre-allocated. Once a value is consumed on any node, it is burned for that table forever. No retry, no reuse. You might see gaps. You might see jumps. That is the visible artifact of parallel causality. What you will not see is collision. In this model, your surrogate key sequences are not just implementation details. They are the visible edge of the underlying physics. A monotonically increasing, never reused series of big ints is how the engine exposes the fact that every row was anchored exactly once. If you strip identity columns away, you remove those anchors. You are back to a world where identity is an emergent property of business keys and timing, where replay is probabilistic, where AI is grounded in graphs that can be reconfigured by code changes. With them, you have a causal fabric. Facts cannot float free. Dimensions cannot be silently overwritten. Backfills cannot remap history without leaving scars in the surrogate space. The system still does what you tell it, but now, when you tell it to lie, it will lie in ways you can detect. That is what an anchor does. It does not make the ocean calm. It makes your position non-negotiable. Incident 3, Copilot and the hallucination of certainty. You built the clock, you wired the anchors. Now you handed the whole mechanism to an interpreter and asked it to speak. You enabled Copilot. From Copilot's perspective, your estate is not a mess, it is a graph. Tables, relationships, measures, documents, logs. It traverses that graph exactly as exposed. It does not infer ethics, it does not infer architecture. It treats everything it can see as intentional. You ask a question that every executive eventually asks. Show me everything we know about this customer. Copilot fans out. It hits the warehouse, it hits the Lakehouse, it hits semantic models and SharePoint files and Teams chats summarizing incidents. It sees 3 customer rows that match the same natural key. It sees facts bound to each. It sees tickets, invoices, churn risk scores, and meeting notes referencing all of them. You experience that as one human. The graph does not. The graph presents 3 nodes with partially overlapping evidence. Copilot does exactly what a probabilistic model is trained to do: interpolate. It merges attributes, picks stronger signals, fills gaps. It writes you a narrative. It tells you this customer's lifetime value, recent complaints, regions of operation, and open risks. It synthesizes across the duplicates you allowed, smoothing contradictions into prose. From your chair, this looks like hallucination. From Copilot's chair, this is obedience. Copilot did not hallucinate reality. It interpolated your ambiguity. You try to fix it at the prompt layer. You constrain scope. You say only use this data set. You add grounding rules. You specify that customer business key is unique. None of that changes the underlying fact that in storage, that column is not unique and never was. Retrieval augmented generation makes this worse, not better. You build a vector index over documents that reference customers. You embed emails, contracts, call transcripts. You attach metadata linking each chunk to a customer key from the warehouse. That key is already ambiguous. Your index now encodes that ambiguity into dense vectors. At query time, RAG pulls multiple chunks for customer 123. Some belong to the original entity, some to the forked clone created during a migration, some to a temporary placeholder ID that was never cleaned up. Similar text reinforces the retrieval because vector search reads it as corroboration. Copilot sees multiple pieces of evidence that all seem to agree. It raises its confidence. The answer becomes more fluent, more detailed, more wrong. You are not watching spontaneous fiction. You are watching a stochastic parrot amplifying the structural indecision of your identity graph. The more richly you describe your entities in unstructured form, the more surface area you give the model to entangle them. Deterministic identity is the only break. When the warehouse owns surrogates and everything that matters, facts, documents, features, binds to those surrogates, Copilot's retrieval layer has a stable join key. Vector stores can index chunks against engine-owned IDs instead of business tokens. RAG can retrieve all and only the evidence attached to that surrogate. If that surrogate is wrong, the error is singular and correctable. Fix the mapping once, every downstream answer shifts in a traceable way. Without that surrogate, fixing one manifestation of ambiguity leaves countless others untouched. The model continues to interpolate across a graph that never snapped to a single truth. You will not deprobabilize AI. That is not the point. What you can do is remove unnecessary randomness from what it stands on. Identity columns do not make Copilot deterministic. They make the substrate less incoherent. They ensure that when the model invents, it is inventing at the edge of knowledge, not in the void created by your refusal to enforce who is who. You wanted Copilot to reveal insight. It revealed architecture. It showed you that without engine-level identity, every confident sentence about a customer and an employee or an asset is built on top of a graph that never decided which node was real. AI did not create that problem. It just executed faster on the ambiguity you allowed to exist. Systemic trust versus human belief. Up to now, you have treated identity as a matter of belief. You believe a column is unique because the specification says so. You believe a pipeline is safe because it has always worked. And you believe a model is trustworthy because it agrees with the prior report. None of that is systemic trust. It is habit wrapped in narrative. Systemic trust is different. It is not about how you feel. It is about what the engine enforces. When Fabric generates a BGINT identity, it is not asking for your agreement. It is asserting a constraint you cannot bypass. That is systemic trust. You can rely on a property precisely because no human can casually violate it. Your beliefs sit on the other side. You believe guides solve uniqueness. They do not. They solve collision probability at generation time. They do nothing for referential integrity, replay determinism, or entity collapse. You believe hashes are good enough. They are not. Change the hash definition and every prior key becomes obsolete. You believe governance documents matter. They do not at runtime. The system does not read your Confluence pages. It executes your DDL. This is the psychological pivot identity columns force. You are no longer the final arbiter of identity. The engine is. Your role shifts from assign keys to declare where enforcement is required. Once you create an identity column on a warehouse table, you have ceded control over sequence, over reseeding, over manual inserts. You have accepted that determinism is more important than discretion. Human intuition is a source of entropy. You are biased toward convenience, readability, and short-term fixes. You are biased toward exceptions. Just this once we will backfill directly into the key. Just this once we will reuse this range. Just this once we will correct IDs in place. Systems do not operate in just this once mode. They operate in always mode. Every time you smuggle identity decisions into an ad hoc script or an emergency notebook, you create a precedent. The platform will happily scale. Identity columns are designed to remove those escape routes. No identity insert, no reseed, no control over allocation strategy. The engine does not trust your exceptions because exceptions are how entropy wins. You might experience this as hostility. You are blocked from repairing data by hand. You cannot compress gaps to satisfy auditors who want clean sequences. You cannot align warehouse IDs with legacy keys to make cross-system debugging easier. Every attempt to bend the physics runs into a wall. That is the point. Systemic trust is built on the absence of special cases. Once the warehouse owns identity, every write is subject to the same rules. Pipelines, notebooks, one-off scripts, they all pass through the same enforcement. You lose flexibility. You gain invariance. This is why best practices are irrelevant here. A best practice is a recommendation that can be ignored. An identity constraint is a law the engine will not relax. Governance documents are paper shields. They decay under staff turnover, vendor change, and operational pressure. Engine-enforced identity does not care who is on call. It does not care which consultant wrote the last pipeline. Fabric is neutral in this. It does not praise you for using identity columns. It does not warn you if you choose not to. It simply exposes the consequences of both choices faster than your prior platforms. When you rely on human belief, divergence appears sooner. When you rely on systemic trust, divergence is pushed to the edges where architecture is genuinely ambiguous. Your job at this point is not to negotiate with the system. Your job is to decide whether you accept a world where identity is enforced by physics or a world where it is negotiated in code reviews. One gives you deterministic replay, auditable lineage, and bounded AI ambiguity. The other gives you stories you tell yourself about how things should work. The system does not listen to stories. It executes constraints. The end of best practices. You were trained to believe in best practices. You wrote them into wikis. You put them on slides. You embedded them in code reviews. Always use composite keys here. Never trust this upstream field. Remember to deduplicate before loading gold. Entropy treated those sentences as background noise. A best practice is an optional behavior. It is a social contract. It assumes continuity of memory, continuity of staff, continuity of context. None of that exists at scale. Teams change. Vendors rotate. Requirements shift. Deadlines compress. Under pressure, best practices are the first thing to go. Identity does not survive on suggestions. If a rule can be broken by a tired engineer at 2 a.m., it is not protection, it is decoration. Your entire identity strategy has been built on that kind of decoration. Guidelines about natural keys, conventions about hash definitions, shared understanding of which columns really mean the same thing. The system never read any of it. Fabric is not hostile to your best practices. It is indifferent. It executes only what is encoded as constraints and DDL. Every other instruction is commentary. When you tell a team, we prefer GUIDs for identity, Fabric hears nothing. When you tell them, never backfill directly into this table, Fabric hears nothing. When you tell them, this column is unique by business definition, Fabric hears nothing. This is why identity columns are not a recommendation pattern. They are required physics. You are not encouraged to use them. You are constrained by them. The moment you declare a big int identity, you convert identity from culture to law. No future optimization, no emergency fix, no consultant shortcut can bypass that column. The engine will allocate values. The engine will refuse overrides. The engine will retain gaps. In that world, best practice loses meaning. You do not have a best practice for using gravity. You have a description of how it behaves. Identity columns move identity into that category. They are not subject to design debates. They are a property of the platform you either align with or fight against at your own cost. Look at your existing governance. Pages of standards about naming, about SCD types, about surrogate key semantics, all of them premised on the idea that humans will remember and comply. Now map those documents against the incidents you have already seen. Duplicate customers, forked entities, AI interpolation. Every failure is a place where someone treated a best practice as optional. The lesson is not that you need more training. The lesson is that identity cannot be left in the space of advice. Fabric's move is clear. It is shifting from recommending patterns to making certain classes of failure materially impossible. You cannot accidentally reseed an identity. You cannot casually insert your own values. You cannot tune allocation to satisfy aesthetic preferences. Those guardrails are not UX choices. They are entropy controls. This is the end of we prefer. In the old world, you preferred surrogate keys. In the old world, you preferred deterministic joins. In the old world, you preferred replayable pipelines. In practice, you accepted exceptions whenever they were convenient. The accumulation of those exceptions is what you now call technical debt. In the new world, you either encode a property as a constraint or you admit it is negotiable. If uniqueness matters, it lives in an identity-backed key with a supporting index. If referential integrity matters, it lives in foreign keys to that identity. If replay determinism matters, it lives in the expectation that identity columns will regenerate the same graph under the same transformations. Everything else is commentary. Best practices do not disappear. They relocate. They become about modeling choices above a layer whose physics you no longer control. You can debate grain. You can debate type handling. You can debate SCD strategies. You do not debate who owns identity. The engine does. This is uncomfortable. It removes the illusion that craftsmanship alone can keep a platform safe. It exposes the fact that many of your proudest patterns were fragile because they relied on humans never slipping. It replaces pride in cleverness with respect for constraint. That is the point. You were never going to out-remember entropy. You were never going to out-document it. You were never going to out-govern it. The only sustainable defense was always the same: move identity out of the zone of preference and into the zone of enforcement. Fabric has now given you that mechanism. Whether you use it is no longer a matter of best practice. It is a matter of whether your architecture deserves to be trusted at all. Determinism at scale. So far, everything I described holds on a single table, a single pipeline, a single replay. Now extend it to the only scale that matters, your estate. At small scale, you can mistake luck for architecture. A handful of tables, 1 or 2 pipelines, limited concurrency, human memory covers gaps, tribal knowledge patches missing constraints, When something diverges, you fix it in place and move on. At scale, those tricks stop working. A serious fabric deployment is not 10 tables, it is thousands. Multiple warehouses, multiple lakehouses, mirrored sources, dozens of teams shipping transformations independently, hundreds of pipelines executing in parallel across time zones. Entropy multiplies with every new boundary. Every source system has its own opinion about identity. Every domain has its own partial key. Every integration introduces another mapping. Without engine-level enforcement, each of those opinions is free to drift. You do not get one identity problem. You get a combinatorial explosion of them. Determinism is no longer an aesthetic preference. It is the only viable survival strategy. Identity columns are what make determinism composable at that scale. When each warehouse table owns an identity-backed surrogate, the cost of joining two domains is not hope their natural keys align. It is define how their surrogates relate. That is a finite, local decision. Customer to policy, employee to device, asset to location. Each link is a foreign key between engine-owned anchors, not a heuristic over ambiguous tokens. Lineage becomes tractable. At small scale, you can trace an issue by eyeballing rows. At large scale, you have no such luxury. You need automated systems that can say, this report cell depends on this gold table row, which depends on this silver row, which originated from this raw file, which came from this upstream feed. Without stable surrogates, that path is fuzzy. With them, it is a chain of key references. Replay events become regression tests. When you touch a critical transformation in a mature platform, you cannot rely on intuition. You must know whether the change preserved identity or mutated it. A deterministic estate lets you do that. You replay a slice of history in a shadow environment. You compare surrogate graphs. If keys and relationships line up, the change is safe. If they diverge, you have a controlled failure. This is impossible if identity is emergent. At scale, emergent identity produces phantom deltas on every run. Keys flip, relationships drift. Your diff tools show massive change where none exists, and you lose the signal of real divergence in the noise. You stop trusting your own validation. You start shipping blindly. Deterministic identity also constrains blast radius. When every table has an engine-owned surrogate, a bad transformation can corrupt attributes, but it cannot silently respawn entities. The anchor remains. Downstream systems may see wrong data, but they see it attached to the same keys. You can roll forward or back while preserving referential structure. Without that, every incident risks structural collapse. A misconfigured backfill recomputes hashes differently. Suddenly, foreign keys no longer match. Joins return empties. AI features break silently. Fixing it is not a correction, it is a resurrection effort. Finally, determinism is what allows you to centralize without surrendering control. Fabric's promise is one lake, one platform, many domains. That is only coherent if every domain can rely on the platform to enforce the invariants they declare. Identity columns are the primary invariant. Once a team commits to engine-owned surrogates, they can publish artifacts, knowing that no other team's pipeline will accidentally remap their entities by fixing a shared business key. This is systemic trust projected across organizational boundaries. If you try to run a global analytics estate on probabilistic identity, you are building a distributed guessing machine. It will work until the day it matters most. At that point, every ambiguity you tolerated will surface together, and you will not have the tools to distinguish noise from failure. Deterministic identity at scale is not optional. It is the minimum requirement for claiming you have a platform at all. The post-human data platform. You have been treating the platform as an assistant to your judgment, a place to store what you already believe, a place to calculate what you already decided matters. Identity columns invert that relationship. They are the first visible sign of a different kind of system, one where the platform's physics are not suggestions you bend, but constraints you submit to. A post-human data platform is not a place where humans disappear. It is a place where humans no longer arbitrate fundamentals the system can enforce better. Identity, referential integrity, replayability, lineage, these are no longer topics for design meetings. They are properties of the substrate. Your work moves upstack into modeling, semantics, interpretation. In that environment, data quality stops meaning cleanup. Today you run campaigns to deduplicate, to standardize, to reconcile. You buy tools that scan for drift and raise tickets. You accept that a portion of every quarter is spent scrubbing what should already have been correct. All of that activity exists because identity was negotiable. When the warehouse owns identity, quality is enforced upstream by exclusion. Rows that violate constraints do not need cleansing. They fail to exist. Pipelines that attempt to bend identity do not need documentation. They fail at write time. Ambiguity does not accumulate silently. It bounces off the physics of the platform. Fabric is one step in that direction. It is still recognizably a Microsoft product. It has workspaces, items, permissions, UI. But underneath, the trend line is clear. More of what used to be best practice is becoming non-configurable. Identity without seed or reseed. No identity insert. Distributed allocation that you cannot tune for aesthetics. This is not a loss of power. It is a reallocation. You gain a platform where every table that matters can be treated as a deterministic component. You can compose them. You can reason about them. You can subject them to automated proofs. Identity columns are the hinge that makes those proofs meaningful. Imagine the full extension of this trajectory. Dimensions and facts with enforced surrogates. Foreign keys that are not just hints to the optimizer, but requirements for rights. Pipelines that are declared, not scripted. Data contracts that either satisfy identity constraints or fail. AI systems that can only be grounded on constrained graphs, not arbitrary joins. In that world, governance is not a committee. It is a set of compiled constraints that the platform enforces in real time. You are not there yet. Fabric is not that system today, but identity columns show where the platform is willing to draw hard lines. It will let you build an entire lakehouse full of probabilistic identity if you insist. It will also give you a warehouse where that ambiguity is no longer necessary. The post-human aspect is simple. The system does not trust your memory. It does not trust your documentation. It does not trust your intention. It trusts only what is encoded as physics. Identity columns encode one piece. More will follow. Your role adapts or it becomes obsolete. If you keep fighting the engine, recreating identity in code, bending keys to match legacy formats, demanding control over sequence, you are not preserving craftsmanship. You are injecting noise into a system that is finally capable of operating without you in the critical path of every insert. If you align with it, your work changes. You design domain boundaries around engine-owned anchors. You specify where constraints must exist. You treat replay as a contract, not a hope. You let Fabric's neutrality do the thing humans have consistently failed to do at scale. Refuse exceptions. At that point, calling this Microsoft Fabric is almost misleading. Names and logos sit on the surface. Underneath, you are interacting with a deterministic environment that executes beliefs as code and rejects anything that contradicts its physics. Identity columns are not an add-on to that environment. They are a declaration of its nature. The clock now ticks. The anchors now hold. Whether you approve is irrelevant. Conclusion: acceptance of reality. The system did not change. It always executed exactly what you enabled and tolerated. Natural keys drifted, hashes rewrote history, application sequences collided under concurrency. The Lakehouse accepted every contradiction. Copilot interpolated every ambiguity. None of that was a surprise to the platform. It was deterministic behavior applied to non-deterministic identity. What changed is you ran out of places to hide that fact. Identity columns in Fabric are not a new capability. They are the formal acknowledgement that identity was never a business concern. It was always a physical one. You tried to manage it with culture, conventions, guidelines, and clever code. Entropy treated each of those as optional and one. Engine-level identity is the line where that stops. Once the warehouse owns surrogates, your stories about how things work are either backed by constraints or exposed as wishful thinking. Replay either regenerates the same graph or proves divergence. AI either grounds on stable anchors or reveals the incoherence of your models. There is no room left for comfort in ambiguity. You are not being asked for agreement. You are being shown the execution trace of your own architecture. If identity columns feel restrictive, that is because every freedom you lost was a vector for decay. If they feel obvious in hindsight, that is because every incident you recognize now was a predictable consequence of refusing to let the engine do what only it can do. You can continue to simulate physics in code, or you can accept that physics belongs in the engine. Without deterministic identity, your platform is a clock that moves hands without proving sequence. With it, the ticks are real, the anchors hold, and replay is a test instead of a reconstruction. There is nothing to celebrate here. This is not a feature launch. This is the moment you admit that running an enterprise data system without engine-enforced identity was never an option. It only looked that way while Entropy was still ramping. Now the system has made that visible. Acceptance is the only rational response.